Hello everyone, thank you for having me. My name is Ali Kouche, PhD student at Griffith University. First of all, I would like to thank all co-authors who helped me with this study, Dr. Etemad Shahidi, Dr. Cartwright, Professor Tomlinson, and Ms. Hosseinzadeh. The title of this presentation is The Comparison of Empirical Formulae for the Prediction of Mean Wave Overtopping Rate at Armored Sloped Structures. The outline of this presentation is as follows. First, introduction, then methods and dataset will be discussed, and finally, we will have results. Armored sloped structures are used to provide the safety of their lee side against wave attack and the accurate estimation of wave overtopping, as the hydraulic response of these structures is an important factor in the design process. Generally, wave overtopping is related to structural geometry and wave characteristics. Empirical formulae are generally used for the estimation of mean overtopping rate, which have been derived from laboratory measurement. Dimensionless measured overtopping rates are correlated with the dimensionless structural and wave parameters. The purpose of present paper is to evaluate the performance of existing empirical formulae for the prediction of mean wave overtopping rate at armored sloped structures, including different armor types such as rock concrete cubes, as well both impermeable and permeable cores. The new EuroTop 2080 database, including more than 13,000 wave overtopping tests, were used, which is an extension of CLASH database. In order to select reliable and relevant data, different filters were applied to EuroTop database. First, the following records were excluded: the records with the lowest reliability and the highest level of complexity. Then large-scale tests were removed because of the scale effects, and very low overtopping rates were also removed as they can be affected by the larger overtopping events. Simple slopes structures with the tangent between 0.5 and 0.75 with emerged crest and without wall at the crest were selected. Records with surface roughness factor between 0.38 and 0.60 were selected, which covered a variety of armor layer types with both permeable and impermeable cores. A total number of 1339 records were finally selected for the further analysis based on the relative crest freeboard values, which is between 0.017 and 2.83, and based on wave steepness values. This study covers low crest and high crest structures and both sea and swell waves as well. The list of used formulae to predict dimensionless mean overtopping rate can be seen in the given table. The classic formula of Owen and Vandermeer and Janssen, the latest formula proposed by EuroTop 2080, and Jafari and Etemad Shahidi formula based on the Model 3 were used. Accuracy metrics such as bias and root mean square error were calculated to quantify the overestimation, underestimations, and the scatter of results. This figure compares the performance of mentioned formula for the prediction of mean wave overtopping rate, where the solid line displays perfect agreement and dashed line represent 10 times overestimation and underestimations. As can be seen, the scatter of results becomes more at lower overtopping rates. Also, JES formula has less scatter in general, as the predicted values lie between 10 times over and underestimation lines. The significant underestimation can be seen for both Eurotop and Vandermeer and Janssen formula, especially for low predicted rates. On the other hand, for the high rates of mean overtopping, the Oven formula shows good performance, while it clearly overestimated most of the low rates. This table also compares the accuracy metrics obtained from different formula. By having negative bias values, both Eurotop and Vandermeer and Janssen formula underestimate the dimensionless mean wave overtopping rate at armored sloped structures. On the other hand, a significant overestimation can be seen for Oven formula with bias equal 0.91. Among all formulae, JES with a bias of 0.013 and a root mean square of 0.61 has the best performance. Surprisingly, Oven and Vandermeer and Janssen as the classical formulae give lower RMSE than that of Eurotop 18. Thank you for your attention.